everyone, and welcome to Activity 5. Today we are going to start talking about logarithms, but first we are actually going to talk about a little bit of review of our exponent rules. So a reminder, when we are taking the square root or an a root of a value, it's the same thing as writing our base to the 1 over a power. So for instance, if we are in fact taking a square root of a number like 16, that's really the same thing as saying 16 to the 1/2 power, which is going to end up being 4. When we are multiplying exponents with the same base, what we do is we end up adding their exponents. So for instance, if we have 3 squared times 3 to the first, that's the same thing as saying 3 to the 2 plus 1 power, aka the third. So this would end up being 27. When we are raising an exponent to a higher power, we end up multiplying the values together. So it's a times b on this one. So for instance, 4 squared but to the third power is 4 to the 6th, which is 4,096. When we have 1 over an exponent in the base, that's the same thing as writing it to the negative a power. So for instance, 3 to the negative second power is the same thing as saying 1 over 3 squared, which would end up being 1/9. When we are dividing exponents with the same base, you will end up subtracting the numerator minus the denominator. So 4 to the third over 4 to the first is the same thing as saying 4 to the 3 minus 1 power, or 4 squared, which is 16. When you have multiple things being multiplied inside parentheses and then raised to a power, they both get raised to that power. Think about it like you're distributing it through to both powers. So for instance, 4 times 2 both to the second power is like saying 4 squared times 2 squared, aka 16 times 4, which is 64. And then last but not least, anything to the 0 power is 1. So 3 times 4 times x times y times z, all of that to the 0 power, well, that's just going to be 1. Now, why are we reviewing these exponent rules? Well, they are essential to our logarithm rules because oftentimes converting between forms is going to be useful in helping us solve. So for instance, we know that if we have a base of an exponent to some power, it's going to equal a number. Well, if we convert this to logarithm form, the log would have the same base as the base of the exponential, and then we would put the number, and then that's going to equal the power. So what I like to call is this little swoop-de-swoop method. If we always start with the base and kind of move around, it ends up being the same order when we write them. Okay, and again, base is going to be our variable b here, and that's always the same for both of the exponent and the logarithm, so it's important there. Now, anytime we take a log with a base of that value, right, the exponential with that same base, these are essentially canceling out, and it ends up just equaling that exponential value. Or on the flip side, if we kind of rearrange this, if we take an exponential to a log with that same base power, again, these essentially cancel out, and you are just left with whatever that exponent is. So again, they basically are canceling with each other. The last one is anytime we have log with a base of 1, well, that's going to equal 0. And that is because when we take the exponential form of that, right, kind of rewrite it, b to the 0 power equals 1. And base, that's actually up here based on number 7 that we talked about before. So oftentimes converting between these logarithmic and exponential forms will help us solve. So for instance, on this first one, we're just rewriting these into their equivalent form. So in this case, from exponential to log. So we'll start log with the base that is the same as the base of our exponential, so 3. And then we went over to 81 and cut back to 4 to get that value there. And if we want to rewrite this logarithm in exponential form, the base of the log is the base of the exponential to that negative second power equals 1 over 16. There are 2 for you to try down here. This first one in part C, you are going to rewrite this exponential as a logarithm. And then for part D, you're writing the logarithm as an exponential. Now, as we move on to the next page, we want to be able to evaluate the following. So change sometimes the form to an exponential to help us find this and solve for x. So for this first one, if we are looking to find the value of x, if we rewrite this as an exponential, 6 squared equals x, so x equals 36. For the next one, if we rewrite it, think about like this equaling x, right? If we want to solve this, we would take 3 to the x power equals 729. Well, 3 to the 6th power is 729, so x is going to equal 6 this time. For the next one, again, if we kind of think about this as equaling x, if I want to evaluate this, I'm going to take 7 to the x power equals 1 over 49. Well, reminder that if we rewrote, for instance, 49 as a base of 7, this would be to the negative second power. So our x value this time is going to be negative 2 to get those to match. Right. Next up, notice our x value this time is actually in the denominator, or is in the base. So our base is x to the 3rd power is 343. And you may need to guess and check on this one a little bit, but 7 to the 3rd power ends up being the 343. So our x this time is going to be 7. All right, again, we have one where we are going to fill this in with an x. So we have 1/3 to the x power equals 27. Well, if we want to kind of think about this as instead of 1/3, you could think about it as like 3 to the negative x power, right? Kind of because we can write it up like that, is the same thing as saying, okay, well, I know this is 27 is 3 to the 3rd. And if I think about setting these equal, well, my x value would have to be negative 3 in order to get these to match. Try number 5 on your own. You are figuring out what x is, evaluating that on that one. Try it yourself. And then we have letter G on this one. Reminder, when we are taking the log of a base and then the exponential's base is the same thing, talked about this on the last page, they end up canceling out with each other. So for this one, we can just cancel because the log with the base of 2 will cancel with that base of 8 or base of 2, and we are just left with 8. On this next one, the exponential base of 7 cancel with the log with the base of 7. And we are just left with 28. Now, we will get more into this, but how do we type this into the calculator? So let's say we want to double check any of these. For instance, if we look up above at example B, we can always type this into the calculator using math alpha math. Okay? And that, if your calculator is new enough, is going to allow you to type this in. So base 3, 729, and we can get that final answer there of 6, which is what we got by converting it to an exponential as well. So again, if we look down here, we see that value there of 6. You can also do this with ones that aren't going to work out quite as neatly. Again, math alpha math to double check this. For the second one, we have a base of 19 and then 2/7. and we get an answer, if we round to like 3 decimal places this time, negative 0.425 would be the approximation. Now, what if your calculator doesn't do math alpha math? This is where we talk about officially what's called the change of base. So we can type this in. Your base will always go on the bottom. So we can type this in as log, and you could use the common log or the natural log. Usually I like to use common log of 2/7 divided by log of 19. So log of 2/7 divided by, make sure you close that parenthesis, log of 19. Right? If your calculator does not have this pretty print, you could still get that exact same answer by typing that in. Right? Same thing if we look at the first one again, we would take, again, the base would go on the bottom, the log of 3, and then log of 729 would be on top. So log 729 divided by log of 3. Again, we should get, did not close my parentheses. See on that? Make sure we close the parentheses on this. 729 divided by log of 3. You can see why these are so important. We get that value of 6. Okay. We will work much more with these in class, but thanks everyone for watching.